Testing, testing, testing. Okay, I'm going to assume that is good enough. Okay, welcome to Programming Rainbow. In this video, I'm just working on some stuff myself. So there's just some live coding. Maybe you can kind of see what I've been working on a little bit. So I'm not really teaching anything, but I can answer any question. And so this is what I'm doing in this, what I'm working on right now is making a neural network that will be trained in Bash and be used in Bash. So this is not using any third-party libraries. This is not using any math, anything special. This is using the built-in Bash. So, all logic, everything that's happening is happening in Bash. All the math that's happening is happening in Bash. There's no anything else. It is used in this yellow snow game here, which is using my my shell to SDL bridge. But again, all the logic and everything that's happening for the neural network is happening strictly inside of Bash. I am using C right now also to iterate quickly on how I'm training this and thinking about the logic. So I am doing some stuff in C, but that's not the focus. That is just a tool for me to basically understand how the network works and the best way it works, since I can iterate faster in C, but then I can re-implement it in Bash as well. I already have an implementation fully working in Bash, but the training bit, I wasn't happy with where it was going, so I switched over to C so I could work quicker, because it could take quite a while to train something in Bash, depending on what size your network is. And if you're kind of looking for a needle in a haystack, it takes a little bit more time. But again, the end goal is training in Bash, running in Bash. But I am using a C for my own internal, and I'll leave access to that at some point as well. So if you kind of want to see the stuff that I'm talking about here, let's go over to see. You can go to github.com, Programming Rainbow, and this will be part of. I don't think the code for the AI stuff right now is live here, but everything else is the ShellGame SDL2 version. And so this is the kind of Bash /ZSH to SDL2 bridge that allows you to make games in the terminal. And there is some examples, there's this yellow snow game, which is the one I'm adding the neural network to. And that's already actually running. I already have this running fully in Bash. The training part I am still playing with between Bash and C and stuff, but the actual using the neural network is fully in Bash. I also did Conway's Game of Life. This turned out to be a little bit harder than I thought it should be. So I end up using all the CPU cores to do this, because it's just it's the size of the array. The smaller the little squares and the more of them you have, the bigger the problem this becomes. But anyway, there's a working version of that. There is the kind of beginner's guide in the ShellGame here. And there's a little test program to show how the mouse movement and the button clicks works and stuff like that. And one about text spinning around and stuff like that, and sprites and things. They're just kind of little test programs. There is also, I tried to do best documentation. I'm not sure if it's all there and it's perfect, but I attempted to do a good job so anybody else that wants to use this can kind of read through. A lot of it's kind of self-explanatory once you kind of get the idea, and there is a little example project here, which I tried to document a lot with comments and stuff, and put more stuff in than actually needed, just to kind of show what is happening here. Okay, so let me just show, for anybody that hasn't seen this, let's start out showing with the this neural network, yeah. So that's okay. So like I said, I'm doing some work in C. This is strictly part of the training thing, because I broke out of strictly Bash because I wanted to iterate faster. And then I had a bunch of ideas, and I wanted to do multiple hidden layer sizes and have it optional. So I'm going down a rabbit hole that I'm working on. But we can see just the actual thing. Here's a bunch of pre-trained networks that I've already been working on here. And if we click on one of them here, we can see it's just some numbers. So this is the actual network here. And the first 7 numbers are like metadata, so that the program that's going to use this, the Yellow Snow AI shell script right here that's going to use it, knows how to use it. So this tells it that there are 8. There's one hidden layer that has 8 neurons in it. And this next to is the X and the Y kind of the zone that it's looking at. How much space on each side of the... I'm using the center of the player, X and Y, and the center of each flake. So this 70, I'm looking at a zone from -70 to +70 on each side of the player for the flake, how the flake relates to it. And this is the Y version, the 240. The X one, it has what do you call it? Positive and negative. It has the sign, whereas the Y one does not. It's not important for the Y one to have a sign. And this just tells me, this 2 here tells me how many trials I ran for each game. And that's not really important to running it, but since I am using integers and not floats, I didn't get the... So for each of these games running, I didn't get the... How do you say the average? Because since I'm using integers, I could have lost precision. So what I did instead is I just put what say I'm running two trials. That means each game runs twice. I'm just adding the score of each game, but I'm not dividing it because I don't want to lose precision. So I'm just keeping that total score here, which was 297 for this actual network. And then I know that I did run it twice, so it would be half of that. That's just kind of so I can print out. It has nothing to do with the actual network running. This tells me how many generations that this network went through. So this network went through 500 generations, and this network was this specific one that we're seeing right here got mutated 245 times. Now, all the other numbers after that is the actual network. And the way this is working is Bash can handle arrays, but Bash can't handle 2-dimensional arrays or anything like that. So this is a 1-dimensional array that is the entire network. So the network is, since it's 8 on the hidden layer, I have 15 inputs, and then I have 8 on the hidden layer, and then I have 2 outputs. So what's going to happen here is it's going to say, okay, for the hidden layer, for each neuron in the hidden layer, each one of those 8, I need to have a weight back to each one of the inputs. Okay. So what's going to happen is since I have 15 inputs, there's going to be 15 numbers here. The first 15 numbers are the weights between the first neuron and those inputs. And then there's a 16th number, which is the bias. And then again, so that basically there's 16 for this. And so if we go 16 times 8, we're going to get the number of neurons here. But also it does it for the output. So for the output, we have 2 outputs, and we had 8 on the hidden layer. So there's going to be 8 weights for each one of those 2 outputs plus 1 bias. So that's all it is. It's just a flat network, and it's using integers. And what I'm doing is since I don't want to use floats at all, because floats don't really work in Bash and ZSH. You would need to use like an external math thing like BC or something like that, which is not inside of Bash and which would be much slower. So what I'm doing here is I'm taking the inputs and I'm taking the inputs and I'm multiplying them by 1,000. I'm not actually multiplying them by 1,000, but you can think of it as being multiplied by 1,000. I'm taking since my game always moves by 5, I'm actually multiplying it by 200 because I want the tightest bit of information that could change. So I'm taking those, whatever the input is, divided by 5 to give me the smallest, and then I'm multiplying that by 1,000. And I'm multiplying how much my chance of mutation and how much it will mutate by 1,000, right? Well, I'm not multiplying, it's already multiplied by 1,000 basically because I'm using an integer. And then when I get when I accumulate all the multiples, of the weights and the input, before I give it the bias, I'm going to divide it by 1,000. So my inputs are basically already set up to be 1,000, and how much I'm variant by, since I'm not using a decimal, I'm already saying it's multiplied by 1,000 basically. So if it's 50, that would be like 5%. That would be like 0.05. Thank you. So I'm kind of doing that. So basically, at each layer, however many layers, you have to divide it by 1,000 before the offset, and it seems to work just fine. And I actually implemented, when I was really trying to figure it out, I implemented it in floats with C, just to train an imaginary network. And then I switched over to ints, redid it in ints. I actually started out straight up in bash before I switched over to floats because it wasn't working for me, and I couldn't figure out what was going wrong. So I kind of backtracked all the way back to ints and then to floats and then went forward again. But the performance of my floats versus ints is actually the same. But you have to be really careful when you're dealing with ints because you don't want to overflow. So like I said, every time I move a flake or move the player, I'm actually moving by 5 pixels, because what I'm doing is I'm not using delta time because I want the game to run as fast as possible. So I've locked it into all movements is 5 pixels and then let it run as fast as it wants, as fast as humanly possible. And the game, when I actually do the training, the game doesn't actually exist. It's just mathematically, it's the game. But it is implemented the exact same in the way that it is playing with the graphical implementation. So since I'm always moving by 5, I don't actually need to say I'm going 0, 5, 10. I can just say I'm going 0, 1, 2. So I can divide everything by 5, basically. So when I say I needed to multiply it by 1,000, what I really mean is I needed to multiply it by 200, because that would be divided by 5 multiplied by 1,000 would be 200. And then the inputs, since they're integers, they're already considered to be multiplied by 1,000, because, again, if I wanted to go 5%, I could say 0.050 or something like that. And that would be 50 if it was an integer multiplied by 1,000. So I just used the 50. And then at the end of all the weights for each neuron, when I've multiplied by the weight and then accumulated, I divide it by 1,000, and then I add my bias, which is already in the int form. And so it's basically, since I started with 1,000 multiplied by 1,000, I divide it by 1,000 one time, I'm still in that 1,000 range. If that makes sense to anybody watching, because my inputs were multiplied by 1,000, my weights are multiplied by 1,000, and then at the end of it, I divide it by 1,000 one time. I'm still in that 1,000 thing. So when I go on to the next step, if there's another layer or the output layer, I'm already assumed to be in that 1,000 scale. And the next weights are already assumed to be in the 1,000, and I divide. So I'm always in the 1,000 scale as this goes, because you don't want it to shrink and lose precision, and you don't want it to blow up. So I basically put it into the 1,000 range and then keep it in that 1,000 range. That's the idea. That's enough talking. Let's just see what this looks like. So I'm going to show you the yellow snow one. So this would be examples. And this .sh pipe, this is the pipe version. So what this is, what I'm running right now, is this game right here, which is using the ShellGame. So this is written in bash, and it's running this game Yellow Snow. This is all kind of set up before the game loop. Here's the game loop. It's running this game Yellow Snow, and I'm going to control it. I'm using the pipe backend here. Okay, let me mute the music. That's mute one, and that is the sound effect one, maybe. Okay, so I can move it left and right, and I can collect these. And I think if I press 1, nope, that wasn't it. Press 2, I get the FPS. So this thing is kind of locked at 60. I could tell it to run faster, and this is using delta time. So I could run at like 5,000 FPS, and it would still be fine. The movement would still be the same. However, on the other implementation with the AI, I don't do that. I don't use delta time because I want it to run as fast as possible. So here is the other implementation. There's subtle differences because, again, I'm not using delta time. And I don't actually get any of the information back from ShellGame. I'm actually mathematically figuring out where collisions would happen just straight up in Bash, because that makes it easier to train the AI. So I don't need to say, hey, where is that flake at? I can just say, well, the center of the flake was here, and mathematically, it's so many to the right, would be a collision with the snowman if I got this center of the snowman, so on and so forth. So I made it simpler in the math so I could do the AI simpler. So this is the AI version, and the network we were just looking at, I forgot which one it was. One of these. Sure. There's like 12 of them. So here's 11 that I'm on right now. Let's run this one. And I can't remember if it's going to run flat out. Yeah, it is. So it's running flat out right now. So if we put run, we can see that this is actually running, it looks like about 800 while it's actually running the thing. And it's getting a decent score, actually. This is pretty good. Usually I get around 40. So I got 132. So that's with me having the FPS kind of unlocked. Let's put the FPS back to normal. So I'm just going to comment out this one where I'm trying to set the FPS to 10,000. And now it should be locked at 60. And we'll run the exact same one. So we can kind of see it does favor going to the left. It always seems to favor going to the left. I'm not exactly sure why that is. It doesn't seem to be anything in my code. Yeah, but maybe it is something in there. I don't know. But it looks like it's doing pretty good. This is actually doing much better than my implementation in C that I did a while back when I was playing with the neural network in C. This is actually a better implementation, even though this is happening right here in ints, and it's happening in Bash. So all the logic of this right now is happening in Bash. The drawing of it is the bridge, and I'll show you what that looks like right here. So this is the AI one. So a lot of this kind of stuff is the same. It's kind of setting up different things. It's setting up the text, everything else. And the AI part, where is it? So when we're in the playing loop here, right here, I have 15 flakes. So I want to get their relative position to the snowman. So I'm going to go through and get that, and that's so I can feed it into the AI. So let me close this bottom down here. Okay, so basically I have this 0 to 15. This lets me go through the flake. So right here. So for each flake, I'm taking the flake and this is the X. So I have like X's and Y's for each flake in two separate arrays. So I have an array of X's and an array of Y's, which is the X and Y position of the flake. So for say the first flake at the X, I'm taking that position and subtracting the player from it. So this will give me a relative position to the player. But this position gets smaller the closer it gets. So it goes down to 0. And I don't want that. I actually want it to get larger. I want it to be inverted. So I have this thing where it's like the exclusion zone that I'm looking at. Where is it up here? I mentioned it earlier. It's the... Where is it? Because I have to load in the file. So here I'm loading in the file. And then I'm setting some stuff. So here's the range X and the range Y that I'm loading in from the file. So they're actually being set there. This is the range for the X and the Y. So imagine if I'm looking at a range of 200, I don't want it to go from I don't want it to say it's negative 200, say if the flake is on the left side of the snowman. It's negative 200, then it's negative 190, negative 100, negative 50, and then it runs into it, it's at 0, and then it goes positive. I don't want it to do that at all. What I really want it to do is say, if it's at like 200 away, I want to say it's 0. And I want to say it's getting bigger as it gets closer. So I have to know the zone I want and then invert it. If hopefully that makes sense. And there's a sign involved because it could be on one side or the other. So what I'm doing here is I'm doing this. So I have this relative X, which is the X minus the player. And I also want it to wrap around the screen. because if I don't let it wrap, the AI will train to be smarter, to be more towards the left or to the right of the screen and just stop, and it'll just sit there and it'll never get better. It'll say this is a little bit better than the default, and we're just going to do that forever. So to fix that, I just let it wrap around. Whenever it goes off the left of the screen, it comes back on the right, and the snowman has no concept of where the screen is and how big the screen is. It doesn't know. It doesn't know, and it doesn't care. So the flakes to the snowman are all relative. So there is no it's off the screen thing. That's just visually for us. So whenever it gets too far on one side of the screen, it just wraps around to the other. And whenever it sees any of the flakes, it's relative to whatever side it's closest to. So if a flake is, say, since the screen is 800 wide, if the snowman was in the middle, again, it does not matter where the snowman is, but let's just say it was in the middle of the screen, and the flake was at 400 or 800. So the snowman's at 400 and the flake's at 800. That's a 400 difference, right? And if it was at the other side of the screen, it'd be at 0, and that would be a negative 400 difference. But what if the snowman was at 0 and the flake was at 500? Well, 500 is bigger than half of the screen. So instead of saying it's at positive 500, we're going to wrap it around. We're going to subtract the screen width from it. We're going to say it's at negative 300. So that's what's going on. The flakes and the snowman, they do not have any concept of how big the screen is and if they're off the screen or not. It does not matter to them. So the first thing I do here is I make sure that it's a relative flake position from the snowman and also wrapped. So if it's bigger than half of, like if it's a positive number and it's bigger than half the width, then I'm going to subtract the whole width. So it'll be on the negative side closer to it. And if it's a negative number and it's smaller than negative half the width, I do the same thing. I add the width to it. So this gives me right here, this gives me a wrapped around view. The flakes are never more than 400 away. And it just wraps. So then after that, I have this thing about the range, because I also want to flip it. I want the number to grow as it gets to the closer to the snowman, not shrink. So I want to flip it, but also I don't want it to look at everything. I don't want it to go from 400 to 0 or 0 to 400. I want to just only worry about a range. So I think I have the range for the X's at like 60 right now, but I'm going to make it where you can choose the range you want. That's why the metadata is in the network, where whatever you trained it at, it needs to actually be run at the same, it needs to be run the same way that it was trained for the network to work. So that's why that metadata is in the network. So if you train your network differently, it'll play using the way that you trained the network. So I'm doing the, let's see, if relative X is a positive number, and as long as it's smaller than the range, so it's like from 0 to 59, then I'm going to invert it. So I'm going to get, instead of 0 to 59, I'm going to get 59 to 0 or something like that. And if it's outside of that range, it's going to go to 0, and I do the same thing on the negative sign. Hold on a second. Okay, sorry about that. So this allows me to get the range and have the range be getting a number getting bigger the closer it is to the snowman, not smaller. So it inverts it and it gives me a tight range. Everything outside of the range is 0. Let's see here. So if you don't know kind of what I'm doing here with these double quotations, this is just allows you to do math in bash, and it's just integer math. So it's not a subshell or anything. It's just I could do it the other way. I could do this like right here. I'm not an expert in bash, but I could do it like this. Right? That would be like the same. But I don't know if this is faster, but it looks a little cleaner to me. So I'm basically taking this number and, setting it to relative x. Okay, so this gives me, let's see here. So this is the wraparound, and this one here is the range, the x range, and inverted, but it's still with the sign. So over here, I'm doing the same thing with the y. But the y, I don't care about the sign at all, because the y, the flake is coming down. It's going to get, the number's going to get bigger the closer it is to the player. And then the number can get smaller if it was past to the center part of the player. You know what I mean? But it doesn't need to be negative because there's no direction involved. The snowman can only go left or right. I don't need direction involved with the other one. It's making a decision about left or right. So this one, I am doing this, getting the relative y, and then I'm basically, this is just a way, like I don't know if there's an absolute value. Basically, if it's negative, I'm flipping it to positive right here, and then I'm doing the range on it. The same thing where I'm, if it's within the y range, I'm flipping it, and so it's getting a bigger number, not a smaller number, or it's 0 outside of that. And then at the very end, I'm populating this inputs array with this. Now, remember I said I wanted it in the 1,000 range. So I'm taking this relative y, multiplying it by the relative x. That means if a flake is like getting bigger, y on the what part? Let me know what part the y was on. So for this inputs, I'm basically I'm populating an array of inputs now, because this is going to need to be fed into the neural network, yeah? So there'll be 15 inputs. So I'm taking the y position, multiplying it by the x. And the reason why I'm multiplying y by x is because the two things are not important by themselves. You can have let's say the flake is all the way to your right-hand side. Well, it's not dangerous to you, right? So as it comes down the screen, the y is getting bigger, yes, but it's outside of your x range, so like it's 0. So they're multiplied. They don't mean anything to you. But if you are within the x range that flake can actually hit you, the y thing does matter. So I'm multiplying them by each other, and I'm multiplying them by the 200 to put it in that 1,000 range. I've actually used this without it being multiplied by the 200 as well, and it still does work. I think the network has to be trained, will end up slightly differently, but whatever I do on the training side, I need to do exactly when I'm implementing it, when I'm using the network too. So they need to be one for one the same. So this, again, since all my stuff always moves by 5, I don't need to actually multiply something by 1,000, because I want the number to be as small and as tight as possible, but still have the information. So since everything moves by 5, I can actually divide everything by 5. So if I multiplied everything by 1,000, I can now divide it by 5, and I end up getting a 200 instead of 1,000. So this gives me this for each tick of the game. This is going through where all the flakes are, and it's setting up inputs. So this gives me an input array of those 15, right? And now we're going to feed this into the neural network. So the neural network, I always start at 7. And the reason why I start at 7 is because 0 to 6 was the metadata stuff. And that's not the network. So if we look at one of these again, these numbers here, right here, 0, 1, 2, 3, 4, 5, 6, are not the network. They're like metadata, right? The network is at this -9 right here. So I'm just pushing forward to 7, like the first network part. And what I want to do is I want to go through each of the hidden. So I'm going to start with the hidden layer, and I'm using for each one of the hidden layer neurons, I need to take the input and multiply it by the weight of that input. Okay. So the input is in the inputs array that we just created, but the weight of the input is here. So this is the first neuron to first input weight. Here's the first neuron to second input weight, to the third input weight, to the fourth input weight. Do you get it? So I'm using NVChad right now. Let's see. So if you wanted to look exactly like mine, you can just go Programming Rainbow and let's see here. This one right here, this NVChad 2.5. Yeah. So I did a series of videos about this. So like, I'm not doing anything fancy here. The way it looks is literally NVChad, but I've set it up to work with C and to C++ and Go and Haskell and different things like that, right? Python or something like that. So I did a series of videos explaining how I set it up, and this is actually all the information too. Like for each of the videos, kind of explaining, like you don't even have to watch the video. You can just like, if you want, this is basically like adding language servers to the stock NVChad setup. Or yeah, for Neo, to do the different things. Was it tree sitter to get, syntax highlighting, tree sitter to get like formatting, to get syntax to get the LSP, and to get like what is it called, syntax I'm forgetting the name, where it's like checking to see if you're writing things correctly, things like that. And so that's all in here. You don't have to go through all this though. Like if you just want NVChad, you can just grab NVChad, and all you have to do, actually, it's the instructions are here too. Like I back up the nvim folder, and I remove the config. Well, after I've backed it up, because you may already have one. I don't want to delete what you got going on. I do delete the state and the local, and then after that, you need to make sure a couple things are installed: NeoVim, unzip, Lua rocks, a couple things. If you're using the so you can copy and paste from the clipboard in X Windows or Wayland, you're going to need one of these. So then after that, if you just want straight up NVChad, not what I'm doing, but the actual just real NVChad, this is just the command for it right here. This is just like straight NVChad, and it'll just be this stock NVChad. If you want my version, you can not run this one, instead run this one right here, which pulls my modified whatever add-on version to NVChad. I'm not like modifying it, I'm just adding to it. It's just all the setup that I was showing you below. And this one will do that. And let's see if I can even open it up here. CD. So this is kind of this is what you're getting from NVChad. You're just literally getting the configs. It's just NeoVim. It's just a configured version of NeoVim. Excuse me. Mine is a little bit bigger because I've added in different things that I'm the way I set it up, but I explain it in all the videos I have. And let's see here. The like tree sitter. Yeah, like mine, I have everything turned on. If you actually grab mine from the repo here, it won't have everything turned on. Everything will be filled in, but I'll comment almost everything out. So even though everything is like present, it's not necessarily enabled. So let's look at the way I did it here. Let's see. Yeah, some of these might be commented out or not. Nope, they're all enabled. So like tree sitter. Tree sitter does the syntax highlighting for the languages. Yeah, you can see it here. So I have tree sitter, but I don't have Odin enabled or Python or any of these things. So basically, this is the one I'm using right now, and I just like turned everything on probably to see if it was working. I was probably checking for a bug earlier. It doesn't matter to me if everything's turned on. But if you pull my version, I'm going to have everything in place, but I'm going to have things disabled, and you can be like, right, I'm doing Python. Let's uncomment that, and now when I restart, I got Python or whatever. And the same goes for like the language servers. Let's go into LSP config. Do you see here we have clang D is for C and C++. It's like disabled. Go please is disabled. They're all here and present. I've put them in, but I've disabled them. And here and stuff like that. And then down here, like this is like disabled. It's all commented out. So basically it's there, but just because you want to use the version I'm using, it doesn't mean you're like, maybe you're only programming in C and you don't need Go and Haskell and all these other things enabled. So basically I put everything in there from all the videos that I explained how to do everything in all the videos, and then I like disabled them all. So they're there, but you can just uncomment them if you want them. So if you want C, just select that, uncomment it, and now you have the C language server set up. And you would put it up here or whatever too. But yeah, I have videos on it. So like if you look in my, it's been a while since I've done them. I probably have to read back through them, but it all seems to be working still, so it's fine. Let's see. I have a like playlist, and I believe I have a playlist just for the music stuff is like not public. It's just me listening to music. So here's NeoVim. Oh, it says course now. Okay, that's a YouTube thing. So I have literally me setting up how to set up NeoVim. This is just NeoVim for the NVChad version. And then this is me adding C support, adding Go support, adding Python. I actually redid the Dreams of Code because they had a Python video, but it was like not, it no longer works. And this had like, what do you call it? I forgot what it's called now because I've never used it. It has the way to debug Python. And so basically I just re-implemented what he was trying to show in his video, but in the new version for people that were asking. I actually don't ever use it. I don't even use Python either, but I was able to figure it out. And Odin, Haskell. There's also some videos on how I set up like Alacrity that I'm using, and I'm using Fish. I'm using the Fish as my user shell and Alacrity as the terminal, and there's something else. I don't know why it's not in this playlist. Probably in like terminal or something. Weird. I don't know why I didn't do these, but so here's how I set up Alacrity, Fish, Nerd Font for Arch Linux. If you were on it's going to be similar depending on like all of Linux is basically very similar. So this just happens to be the platform I'm on right now. Hello. But yeah, like I said, it's NVChad. So I don't know what they've changed recently in NVChad. Like I said, my setup still works, so I just use it. So it's these guys set up. Yeah, so that's what I'm using. But I've added I don't think they add any language support out of the box. They've just it's just like you can open the side here. I forgot what it's called. It's not tree sitter. It's something else. It's like NV tree or something. I forget. And you can open up terminals, things like that. Yeah. Okay, so yeah, so that was that. Let's go back over to the neural network. So yeah, so basically this is going to loop through. It's going to loop through the hidden layer. So right now this is hard coded for only one hidden layer, but it's going to loop over the hidden layer, and it's going to take. I'm going to put the answers to all the hidden layers like I did in the inputs here in another array called hidden, right? So that I'm just zeroing that out for each of them. They're going to be accumulated there. So I take the hidden layer, let's see, the input right here, and I multiply it by the index. So I'm using this as a flat index right here. And so this is my network right here that I just showed right here. So the very first one is going to be 7 because we start at 7. That gives us our first kind of bit. So this will be 7, the index, which is like -9, I think, multiplied by that, right? And this is going to go a loop over the entire hidden layer. So it's going to run all 8 of those because there's 8 in the hidden layer. And then after that's done, I'm dividing it by 1,000. And then I'm going to add the bias, which is going to be sorry, this is the layer. This is sorry, not hidden layer. This is the input layer, the inputs. Sorry, there's 15 of these. So it's going to go through this 15 times, and on the 16th time, that's going to be the bias. So the first 15 is all the weights. The 16th is the bias. It keeps incrementing this net index on each of them. And like I said, it's divided by 1,000 first, then the bias is added, and then we have the activation function. It's a ternary. I'm just using a ternary. It's going to be a positive number or 0. And then basically this exact same thing right here is going to happen again. But instead of we're using the hidden layer looking at the inputs, this time we're using the output layer looking at the output of the hidden layer. So it's this is the exact same code again. It's just the first one was going over iterating over the entire hidden layer looking at inputs. This one is iterating over the entire output layer looking at the hidden layer outputs. And then once this is done, I actually just left in this stuff so the user can actually still press left and right on these. This is user input held left and right. Just ignore that. But basically I'm saying if I have two outputs, so one's a left and one's a right. So I only want it to move if one of them is positive and the other one is they can either be 0 or a positive number. So if they're both a positive number, I want it to move in the direction that the one that is the most positive. If they're both 0, I don't want it to move at all, right? So this one's checking, is left bigger than right? If left is bigger than right, we're going to move to the left. And this one is checking if right is bigger than left, we're going to move to the right. If they're both equal, if they're both 0, it's not going to move at all. So this is moving the snowman, and that's the entire thing. So down here, this is just updating the game. This nothing to do with the neural network. This is going through all the flakes, and it's, sorry, I think I update the flakes above. No, I don't. Okay. Don't update the flake. Okay, so I'm updating the flakes here. That could be a bit backwards. I might have to think about that one. But this one, I'm updating the flakes by their velocity, which is 5 for this. And again, this is not the way it's done in the other yellow snow one. I'm using delta time and everything else, which would be 300 and all this. But this one, purely for the math. So relative x up here. So what I do to feed into my neural network, I need the relative, I have the flakes. I have all the 15 flakes and each one of them have an x position, and my snowman has an x position. So I'm taking the relative position. So basically my inputs are going to be a relative position for each flake versus the snowman. And there's an exclusion zone, and then I invert it so the number gets bigger as it gets closer to the snowman. And these are wrapped around. I was kind of explaining this all earlier. This is dealing with wrapping to make sure nothing ever goes bigger than half of the screen or smaller than negative half of the screen. So everything's wrapped. And then down here, I am taking a range, this is the X range. And I'm saying if it's within range, I'm going to invert the number. So it starts from 0 when it's out of range. And when it starts coming into range, it goes 0, and the number starts building up as it gets closer to the snowman. So the number is bigger as it's closer. And I still have the sign. It could be a negative number or a positive number. And then I do sort of the same for the Y. I'm getting the relative Y position, but I don't care. I only want it to be a positive number. It doesn't need to be signed. So I'm right here. If it's negative, I'm flipping it to positive. And I'm doing the same range thing here, but it's always a positive number. And then I'm multiplying the X input by the Y because they need to both matter. I don't know what MLP stands for. I don't know all the terminology, sorry. This is the forward feed neural network. This is for, I'll show you real quick. This is written in Bash, and it's to run this yellow snow game that runs in Bash. And we use this 11 neural network right here, and the little snowman is controlling itself right now. So it's he's trying to not hit the yellow flakes. If he hits the yellow flakes, the game is over. So that's what this network is doing right here. And it's just playing itself right now. You can kind of tell because it keeps jittering back and forth whenever it stops. And we can play this faster, right? We don't need... Oh, let me show you again. This is playing at 60 FPS, but this is locked to the FPS because the fact that I want to be able to run this really fast, I'm not using delta time. So right now it's at 60 FPS. It doesn't matter what the FPS is. Every tick of the game, things move by 5 pixels. The snowman can move by 5. The flakes move by 5. So if I were to go up here and I would just say, I don't want it to run at 60, I want to just run at 10,000 FPS, it won't actually run at 10,000. It'll try to. So now if I put FPS on there, right now it's running at like 3,500, but when I start playing the game and it's actually running the neural network, it'll probably slow down to like 400 or 500 or something, or 800, who knows. Yeah, it looks like 700, looks like maybe. Yeah. So this is running as fast as it can possibly run. And it is single-threaded, I believe. The training, my first version of training this neural network in Bash, it is kind of multi-threaded, the Bash version of multi-threaded, but this is just running single-threaded right here. Sometimes it gets over like 100 or 150 is pretty good. So you can see that thing, was doing pretty good. It got to 147. It's just a very simple neural network. It's got one hidden layer. It's, I think this one is size 15. Let me check. We were using 11 here. Is this 11? Go. Oh, yeah. This is 11 right here. This is the one I was just using. This has a hidden layer size of 15. So the network is bigger here. That's why I have this metadata in the beginning of the network right here, just so it knows, oh, I need to iterate over all of these. And, the hidden layer is size 15, not size 8 like the other one. We do have a size 8 one somewhere. Go look. What do we got here? Okay, so network number 1 is size 8. So let's run network number 1. And it maybe won't do as good. I don't know. It looks like it's doing pretty good. Oh, that's pretty amazing. Then it got a 3. And that's 50. So there's like 2 things. Like I keep getting stuck on this. I want to finish this and not do it anymore because this is cool and I want it to be done and I want to show other people, right? But I want to, I have I've been trying to do a game using a complete ECS like a proper ECS, not like I haven't seen a single person on YouTube that shows how to do an ECS, like the entity component system. Like none of them. Okay, like as far as I understand what an entity component system is, none of them are doing it. And there's like these sycophants that are like, "Oh, you showed such amazing job. Look, your ECS," and it's not an ECS. So let we type in. So right, if we type this in here, let's see, like this guy right here. Is he showing? Is this the one? Yeah, it's not an ECS. Like I don't know what he's talking about. But everybody listing below his comments says what an amazing job he's doing, and it's an amazing ECS, but it's also not one. And so that's kind of annoying. So like I have to just figure it's entity component system. So the idea is that every everything is like I can't even explain it properly because I haven't physically done it myself, but everything is like a like your say your velocities are all what is it now? I can't even explain it. They're all, I don't want to say entities or components. They're each of your entity has a bunch of different components that can be in it, right? But they're not actually in it. They're separate things. So you have like all the velocities, all your x's, all your y's. You're not putting multiple that like all your data is one thing. So you have an array of just one thing, kind of like I wasn't trying to do this here, but in here, the way I build up this inputs right here, this inputs. I build up this array of inputs. Those are all just inputs, and then later on, I build up another array of the hidden layer outputs. Those are all just, so that's like an array of just one type of data. There's no, it's the struct of, what do you call it? The struct of arrays versus the array of structs. So an entity component system is a struct of arrays, not an array of structs. So an array of structs would be like you have 20 items in your game. Like you have some entities, you have player, you have grass or whatever. And each one of those is a struct, right? So the struct has like an image in it, and it has an X position and a Y position and whatever it can do, and can it move and things like that. And that's in a struct or a class, if you want to say. It doesn't matter. They're the same thing. So, and then you have an array of all of these. So that's an array of structs. In an entity component system, you have a struct of arrays. So you have like one big old struct, and then it has like an array of. Well, it's for speed. It's for basically, it's about the CPU cache misses and stuff. The CPU can cache things. Hold on a second. So there's several different reasons, but part of the thing is I just want to learn. I just want to understand it because I don't fully like. I'm trying to explain it. I don't. Sorry. Um, so part of the reason I just want to understand it, then I will be able to explain it to other people better. So I don't know if it's better or worse or what things it's better or worse for, but I know the major benefit. Yeah, me too. I'm just like I'm trying to understand things. I was like, this entire shell thing was like, could you make a game in shell? I don't want to make a game in shell. Why would anybody want to make a game in shell? But can you? And then I ended up down this hole of like, now I have a complete running thing to make games in the shell, and that's not even what I wanted to do. It's like nerd sniping yourself. But the entity component system, it's like if you had a struct, and so if you had, say you had 50 characters or 50 entities in your game, your struct would have all the X positions in one array for every entity, all the Y in one like array, all the its velocity, in one array. Oh, so this is called ShellGame. Let me show you real quick over here. So if you go to the GitHub Programming Rainbow, you can pull this. It's called ShellGame, and this is using SDL2 right now as the backend since 3 is not done yet. And what this is it's like a C server that you can communicate, like high-speed communication between Bash and a C server. So I'm calling it like a bridge. It very much looks kind of like if you had a binding, but it's not a binding strictly. And so I went down this rabbit hole of how do you communicate between Bash and C really fast. And it was kind of like funny because the AI was telling me you should use shared memory, and that ended up being the slowest method possible by 100 or 150 times slower. So I have all these different backends. So basically, you pull this. It has a ShellGame server right here. You have to build that server, which is basically a bunch of stuff for it's drawing. It's handling your memory management and drawing stuff for you in SDL. But you don't worry about that stuff. You just like give it commands from Bash. So yeah. So this is me testing out different things. So I can show you like, let's see, where are I have examples. When you pull it down, there's like the beginner's guide, right? So let's look at that. And you can choose the different backends you want to use for communication. So if I were to rewrite this, so a lot of these games I've written in like 10 languages. So like the Yellow Snow one, I've written that in like Python several times, C, C++, this CPP2 that not really a language yet, Go. I've written in Haskell, I've written in Forth, I've written in COBOL. So like I've tried a bunch of different languages. JavaScript, although I've never shown anybody, I actually have JavaScript stuff. I just written enough JavaScript to understand how much I hate the language, and then I've never shown anybody that I can do JavaScript as well, but I hate the language. Yeah, I have videos in Go. So like if you're on my and I have more projects on my thing that I've never even made. Let's see, let's just type in Go here and see what we get. Whoops, that's not Go. So here's some beginner's guide to SDL2 and Go, right? Here's NeoVim Go. This is more. Did I ever do? Yeah, so let's look on here. Maybe I never. I haven't played with Go in a while. Go was like pretty easy. It's pretty good. I like it. So we have this ShellGame thing that I was working on. This is also how to talk between Bash and C, like as fast as possible. I was doing an updated version of SDL2 and C, which is like much more expanded than the original. There's the NVChad. I was playing around with this platformer, and somebody asked me if they could show the code. It's not a real language. It's Herb Sutter. Well, I don't know if it's not a real language. So it's called CPP Front. It's this kind. I don't know if it's a meme. It's a joke. I don't want to make anybody really angry. It's C++, and if anybody knows C++, C++ is a joke kind of in itself. CPP Front. So this is like trying to fix C++ by Herb Sutter, which is one of the main people in the C++ world. And this is his language. So it's like new syntax. Yeah, I kind of try to take them from the thing that you know basics of the language, and I'm just showing how to get the information, like where to look it up and stuff like that. But this was kind of just, again, it's not a real language. If you've seen any of the C++ stuff, you can't fix C++. C++ has jumped the shark so long ago. Like their new, was it 2026 stuff or 2027? It's so insanely bad. Nobody should ever program that way. There's no fixing it. It's just so bad. It's like, this is fixing it. This is interesting though, and it would be cool. Like I like the idea if C++ was to break with C and also break with all the old C++, and they just did one version of things the correct way. That would be okay, but there's no hope for C++. Yeah, Go is very. I didn't have any problems with Go. Like Go is easy. So again, on my thing, I might have some more Go projects that I may not have even filmed. Because I start doing things like, I end up with like, I have asteroids for SDL3. I have asteroids for SDL2 here. I have Yellow Snow for SDL3, Minesweeper for SDL3. This is the neural network one in C, not the Bash one. NeoVim, Conway's Game of Life. So I kind of did a bunch of stuff here to kind of help me understand what I was working with. So here's like the beginner's guide. I have it in, C, COBOL, Forth, Go, Haskell, Love 2D, which is Lua, Odin, Pygame, Pygame 0, and Ruby. Let's see, where's Go here? Isn't it? Yeah, there's Go. So I have that Go one. Did I not? It was probably easy for me in Go, and I got like, how do I do this other thing? You know what I mean? There's nothing I don't like about Go. Go is very good and easy to use, and I think my son did some projects in Go as well. And I end up just like trying to understand something else, and I get like sidetracked a lot. Then I was playing with Odin. I haven't played with Zig yet. I did play with Rust before as well. Yeah. So I end up playing with a lot of different things, and I don't know, like, I want to get to two things. I want to get to game and the entity component system. I want to just do the entity component system so I understand it better, and so if I know if I like it or not, because it might not suit my style or something, or it might. But again, nobody has it. Like this person here, where were they? That were explaining entity component system. He's not right. This is not right. This is not a correct entity component system, and I don't know what this one is either. It's just somebody talking, but this guy, he's actually showing it, and what he shows you is not a struct of arrays. He shows you an array of structs, like mixed information. It's not an entity component system, and it's also in Unity. Why would you be doing this in Unity? Unity already has a system under the table. It doesn't care what system you use. It's already doing its own thing. So I just don't understand it. So I want to build it so I understand it better myself. The one thing is just do the thing and then figure out what's going on. So I end up like listening to what's his name, Casey. Casey Moratori. I'm going to say it more. I'm probably saying his name wrong. But anyway, I end up listening to Casey and then trying to figure out how to do it. I haven't actually watched Casey's videos because he does things in Windows, and I don't have an interest in Windows. But his talks are very good. Like his information is really good. Yeah. Well, what I'm saying is the tutorials. There is no tutorial that I've seen yet on YouTube that has entity component systems. Like again, these are not entity component systems. So yeah, it's like the Forth. So if anybody's ever played with Forth, okay, this is like a huge annoyance to me. Let me just show you Forth. This is what happens to me every time. Okay, so this is my video. My videos on Forth, SDL, which is cool. But this is where I started from. Was it? Yeah, this guy. And I don't want to be mean to this person at all or anything like that. But this is what I get. This is what happens to me when I look up information on YouTube. You get this information that is like not even right, not even correct. So this guy is showing you, well, the Forth is really cool, and you can do, and you can make some SDL stuff in Forth. I'm like, oh, really? You can? I want to try this. This is going to be amazing. It's not. It's smoke and mirrors, and it's like a facade. Because what happens is he has implemented like one function in SDL in Forth to make a window and nothing else. And there is nothing else. And the stuff he alludes to in the video doesn't exist. And I spent like a week looking for it. And there is no, like, you need bindings to use SDL in Forth. And he doesn't have the bindings. He has like just one function or two functions or something like that. And they're just not there. So in the end, what ends up happening is this guy is the number one spot for information on Forth and SDL, and I have to actually create it. And so I end up doing this stuff, which is like, where is the... And I don't know Forth, but now I'm stuck. I'm like, I want to make something in Forth now. This guy said I should make something in Forth. So I end up like in here writing Forth bindings for SDL2 when I have no clue what I'm doing. So it works. So this is like my Forth bindings for SDL2. But this is the thing that like... Yeah. It's just a integer. Yeah. Like I said, I end up like trying things that I like wonder how they would work. So yeah, this whole thing goes on and on and on and on. Like every time I see something, like, where is it? The like this person, it's not correct, and then I'm like, well, can I do it now? And then I saw this other dude, like, what's his name? The dude with the bash with the HTTP server, not S, just the server. Oh, I did it again. The bearded dude, right? So like I was like, well, that's cool. What else could you do in Bash? Like I was kind of thinking before, like, couldn't you just make a game in Bash? But you can't, because you can't do the memory management. You can't call the C functions. Then after I started building it, I found out you kind of can, but it's really slow. So I started going down this rabbit hole of how fast could I send and receive information from a C server? How quick could I do it? What's the smallest amount of time? Is it feasible to make a game? And then I found out, yeah, you can make simple games, and you can you can get that communication working fast enough. Yeah, it is kind of annoying. So like I said, I ended up making, again, this is like, I did not know the Forth language, and I don't know SDL very well. I'm learning it, and I end up making SDL bindings in Forth for the Forth language because I saw some video on YouTube that said you can do this and you can't actually do it. So yeah, so then I was making this Bash bridge, and I also have this neural network, and I'm like, well, can you make a neural network in Bash? And then I'm like, but it can't be, it won't work if it's let me just show the let me show this. So I started trying to train it in Bash. Where is it? Where's my AI trainer? Here's my AI trainer. This doesn't actually work. I need to update it. I kind of like stopped working on this and switched over to C because C is so much faster. Not because I don't want to do it in Bash, but because I just needed to get the answer. Because what I was training wasn't actually working. It's because my logic wasn't correct. So this has basically a mini version of the network, and that's it. And it's not trying to draw anything. It's not doing anything. It's just trying to train itself. And it's what was it? It's using the... Let me close this. When you detach it to the when you use the ampersand to detach it, the process. I haven't looked at this in like a week now. So for right here, I'm basically multi-threading it, kind of. I'm for each of the I don't want to run this single threaded because it'd be way too small. This is again for training the network, not running the network. So I need to train I think I did how many generations did I put up here? So I'm trying to do 100 generations, and I have an input layer of 30, which I've actually switched to 15 now, and a hidden layer of 15, which sometimes I do 15, sometimes I do 8, and I have 4 trials here. My output layer is still the same. And then, so where is it? How many generations? Oh, I'm doing 100 generations. So what I'm doing down here is, up here is all the logic, right, for one of these games. And it's going to run the game until it gets the yellow snow, and it's going to get whatever its score was. But right here, I'm trying to, for 100 generations, I'm just, since I have 24 cores, I'm running one of these networks and detaching it, and I'm getting the PID of it, and then I spin up like all the networks, and then, hold on. So I'm basically, sorry, each one of these is trying to run one of those networks. So I have them all using local, this run network. They're all local here because they need to have their own kind of agency. I'm not an expert bash programmer. I don't know how to do everything amazingly. So I have a bunch of global variables. These ones are local. So I can run this network, and this network runs as many times as there's a trial, but it's only for one of the games for however many trials it is. So now I have the thing of, well, how many generations do I want to run it? So I know I have 24 threads in my CPU. So I'm running it, I'm detaching it, I'm grabbing the PID of that thing, and then I sit here and I wait for them to finish. Don't know why I'm doing 24. I'm trying to remember. For each generation, why am I running? Oh, because the size. Oh, right. I'm doing it. The size, I didn't put it up here, but the size of my population size is 24. So I'm just using my threads as the population size. So I have the threads as my population size. So I'm only doing 24. So I'm keeping the top 12, I think, is what I'm doing on this one. And I'm going to do this 100 times one for each generation, right? So I do my 24 background, then I have to pull them all together. So I'm putting a weight on this. So the PID's done. Sorry, a lot of drama happening here. So yeah, so I'm trying to do 200 as one generation is going to have 200 games inside of it. I'm going to keep the top 12. That's the idea of this one. So I'm basically running batches of 24, and that's going to be one generation. So I'm kind of like, tell it, hey, run all 24 games, wait till those 24 games are. Sorry about that. I don't know what's going on. If it stopped working or something, I tried to restart it. Don't know what was happening there. This one restart too. Yeah. Sorry about that. If I'm not sure what I lost there. So I run them in batches of 24 because that's the size of my population, and I'm gonna try to keep the top 12, I think, on this one. But I'm doing this over and over again for each generation. So I run the 24 when the PIDs are done, when the action was completed. So I'm using a wait on there. I'm going to then read them in, and I just need the index of what that index number was and what score it got, so I can now, because imagine if like the 10th network down the list had the best score. So it's gonna need to be number one, but I need to know it was the 10th network, if that makes sense. So that's I'm sorting it there. So it has the index externally with the score, basically. So then I can resort these. And again, I'm not Bash. I just had to look up some of these things to figure out how to sort things in Bash. But I'm resorting them now. And basically, I want to keep the top 12. And if it's not the top 12, I want to copy that top 12 one down to one of the lower 12. And then I'm going to mutate it. And so, and again, this is not, this is something that I didn't have working correctly. It wasn't doing what I wanted it to do. So I switched over to C because I wasn't sure what the problem was. And this was kind of working a bit too slow. It's fast enough to do the job if it's working, but because of development, you need to develop, like I need to iterate faster when I'm trying to solve the problem in the development. So this was me implementing it in Bash. This is completely in Bash, but also this didn't end up giving me the right question or the right answer. And when I switched over to C, I still didn't get the right answer. And when I switched to floats, I still didn't. And I fought with it for like a week before I started to finally get it to work correctly. So like I've been staring at the C version. So I can show you what this is going to look like. This uses like all the threads basically. Let's see here. This is called what? Sample train AI. So I'll have to re-implement this one with the fixed logic that does work. But right now, it as the way it sits, it's not going to train up very well. And so that just did a generation, right? So you see, it doesn't look like it's too slow, but actually this is super slow. If we look at my CPU, you can see my CPU is like maxed out. Everything is like using 50% basically. Not maxed out, but like it's heavily using it. And you can kind of see the bash is running like, 24 of these things at a time. And so it would go through this for 100 generations, basically. But the problem is even with this, with 100 generations, this was not giving me a good enough score. Like this, the fitness on this one was 1. That's. YouTube just like randomly stops working. That's cool. I don't know why that keeps cutting out. It looks like the other one's fine. It's just YouTube specifically stops working. But anyway, I was messing around with the C code, so I think it's still compiled. So the C code version, my population would be 120. My trials is just 2. And I was doing 2,000 generations, it looks like. So let's see that. And you can kind of see this is much faster. So that this population is 5 times bigger than the population of the other one. And the generation is, what do you call it? 20 times larger. And also this is single threaded. I didn't bother with making this multi-threaded. I have on my other one that's in C, but this is a different implementation. And so this is just single threaded. So right now it's at generation 1000. And if we look at here, top, and we can see that most of my CPU is not doing much, but this one is using one of the, like one of the threads maxed out, but the rest of the CPU is not being used. But I can do it multi-threaded. It would be even faster. Yeah, I got. Yeah, well, I'm using the HX 370 CPU. So this is the output now that it just created the output. So it would initially started with with just filling it with random numbers, and then it's let's see how much we're for this one. The rate. Okay, so I've been putting in numbers in here, so this looks different right before I started recording. But my rate of mutation is like 0. So it's not 5%. It's half of 1%. If there was because everything's divided by 1,000 or whatever. If this was 50 right here, this would be 5% chance of mutation. So I'm running 120, but I'm keeping the top 2/3, I think, right here. Yeah. So the bottom 1/3, those bottom 1/3 is going to get mutated. The top, whatever the top one was, will be put into that bottom 2/3. It iterates over whatever the best ones were and populates the bottom third. And then after it puts that one in the bottom third, then it mutates it. And when it mutates it, it goes over all the weights and biases. And the chance that it's going to mutate one of the weights and biases is this 0.5% right here. And the range that it mutates it by is this 15 right here. So this 15 is a plus or minus. It's actually going to be 15 times 2 plus 1, because since it's an integer, there's a 0 spot. So it'll be, what happens is I'll take a random number that is going to be modulus of 31 subtracted 15, if that makes sense. So it's going to straddle the 0 point. It could be a positive or a negative. It could be like a positive 1 or a negative 10 or a positive 3 or something like that, or a positive 15 or something. But this is basically the range that I'm mutating it. And this can be around from 50 to 5. It seems like it works pretty good in that range. So I basically tried to do the same thing over and over and over and over again. And so switching over to C allows me to find out what's happening and recreate it over and over pretty quickly. Like, this is pretty outrageous, running 2,000 generations of each game is running. Each one of these generations has 120 games, and each one of those games is running 2 times because I'm using two trials. So I'm running 2,000 games, or 2,000 generations of 120 games. So that would be like, is it 2,400,000? Is that right? Or 240,000? Yeah, so I think 480,000 because it's 2 trials, something like that, like 500,000 games, and it took like 1 minute 9 seconds. So that's pretty quick. If I was running it in Bash, it would take longer. But when I do get the answer, I'm putting it back into Bash, because the object of this is to do this in Bash. But the problem is that I was like, well, what if I want to do more than one hidden layer? So now I'm in this thing where I'm rewriting my C code, making it way more complicated than it was originally, adding in all this stuff, and I need these parameters being passed in so I can set the range, and basically overcomplicating what I already had the answer to as a single layer. I already had it, and the code was quite simple, and now I'm making it overly. Let me close this. Overly complex, because this wasn't here before. This parse arguments that I kind of stole some of the code from one of my other projects, and I'm stripping it down to what I need. This wasn't even here before. It was just doing a static, it was whatever I set up here. I would just go up here and say, you know what, I want to run the mutation range at 5%. I would just change this, recompile it, change it to 5, recompile it, and run it. But now I want to make it, and it was the network size is statically calculated here, or it's not calculated here because this is a preprocessor macro, but like the numbers are put in there, and then it's actually calculated at runtime. But this has to be different if it's 2 layers or 3 layers, or it's got to be calculated differently. So yeah, so then I end up with, I need to put ranges in now, so if somebody doesn't put in a number that's way too big or way too small, and I need to put in a name. Like I was literally just copying the information in. I would just printf it to the screen and then just copy it into one of these files. So I just kind of making it more complicated now. So I have these things to check if this is a file name, like it just became way more complicated suddenly. Just because I wanted to give options available. I want to let somebody run this program and just put in a switch of the mutation rate, the mutation range, how many trials they want, population size, the size of the selection of that population that they're going to keep in each generation, how many generations they want to run. And I'm not done yet. Like I said, I grabbed this code from my other C project that had a whole bunch of more switches, and I just started trimming out what I basically needed for this use case. But this was an already finished working code, and yeah, I don't know. See if it's still working. It's still working. That's amazing. In here, yeah. So yeah, that's what I was doing. So I'll probably just keep doing that unless somebody has another question or something like that. So I'm basically making a config up here. This is all just one file still, but I was just kind of, since I'm going to try to have parameters that I can pass, like if I want to give it a file name, instead of copying the information out and dumping it into file, I could pass it a file name and then try to make that file exist at the end. And I'm going to need different amount of metadata in the thing because it's going to need to know how many layers to make. So this one is going to be the count of the layers, and this will be the size of each layer, I guess. So I think I've made it where you can only have 5 layers maximum. That's kind of ridiculous to have 5 here for what this is. And so then each layer could be like, there could be 5 numbers here, and that would be the size of each layer. And this is the population size, the selection size, the trial generations, the mutation rate, mutation range, the X range, and the Y range. Basically, yeah. So I can pass these as parameters. So far I've done the file name, mutation rate, range. Let's just do these in order here. So we have the layer count, yeah, population, selection, trial, generation. So population, selection, trial. Okay, so these are in the correct order. So I haven't dealt with these 2 yet. The population, where I have rate, range, trials, rate, range. Trials should be up here, population selection. Probably maybe grab trials, put it below population selection. Yeah. This one here. Population selection, And these probably need to be up top. Or trials generations. Just call it gen. Oh, I think that's already here. Right. Oh, yeah. Okay. And then these two mutation ones are after those. These two need to be later. Just so like it organized looks correct to me. So I don't get lost with what I'm doing. Okay, so that's most of this stuff. Population selection trials generations, population selection trials generation. We got the rate and the range. This is for new. And yeah. So we have this other problem of the how many layers. So the layers, I think, comes in with the new keyword, I think. Yeah, because it's going to be how many layers. And we have did I put a max layers here? Max layers, yeah. Okay. All arguments. Like I'm not an expert in any of these things. I just try them. Haskell's very interesting. I actually was writing some C. I didn't finish it. I started writing a C project in the style of Haskell. So like you can't actually do it, but you can get very close. The idea was I was trying to write immutable. Did I even put it on? Did I? Hold on. Where I don't know if I put it up. I think I made a video about it, but I don't know if I put it up on. It was like immutable. It was like immutable C. It was like if you were to never mutate anything, but you can't. The problem is you can't do it 100% because like if I calloc something, I can't put the information there when I calloc it, so I technically have to mutate it to move information in. But without caveat or whatever, the rest of it was like non-mutable. What was it called? Like immutable or functional C. That's I did hit a hold on. I hit a major wall with Haskell and I was never able to get an answer to this. So this is part of the reason why I didn't make more Haskell stuff, but also just because I got interested in other things too. But what happens is in Haskell, if the sound is messed up for SDL2 and there's nobody to ask for help. So like I put in like a bug report maybe a year ago on this or something, but I also tried to ask for help a long time ago before AI became a thing. And I tried to go on like Reddit and Stack Overflow and ask for help. And I just got my like I try to present the code I had, but like, could I get a code review of this? And I think there might be an issue with the sound, or I can't figure it right. And they're like, no, you can only get reviewed of perfectly working code. There can't be any bugs in it. And that doesn't exist. There's no such thing as code without bugs in it. And there's no such thing as giving a review of perfect code that doesn't have bugs, because you don't need a review because the code is perfect. So that just like the absolute toxic nature of Haskell and sorry, not Haskell, sorry, of Stack Overflow and Reddit. I would just the way that like you cannot ask anybody for help ever, and the person who is answering your question for help is, say, a JavaScript script kiddie that is closing your question in Haskell when they don't program in Haskell, because they get points for closing answers down. And that's what I had happen to me. And to this day, I've never got the answer to it. So there is a problem. There is a bug in Haskell with SDL where the sound will like cut out on you. And I don't know enough Haskell, and I think you have to go like below the Haskell layer, below SDL layer. I think this is something happening on like the kernel level or something. And there's just no person I can ask to for help, because I actually went to the people who make the bindings for SDL, and I've never gotten a response back from them. Yeah, I don't think it'll ever be fixed. The only way it'll ever be fixed is if it's like the fourth thing in the SDL, where this guy is like, you can do this, and it's like, no, now I have to learn how to do it because it's not real. I would have to, for that bug to get fixed, I would have to understand that bug and fix it myself. And I don't have the knowledge, like I just do not have the knowledge for it. And you can't ask the SDL2 people. They're pretty terrible. Like the SDL2, I know it's an open source project and I don't want to bash them for that and all that, but they are incredibly arrogant and writing like they're like very happy to write very poor quality code and then tell the world to use their unfinished poor quality code. But not to actually help at all. Like I had bug reports into SDL for other problems, just for the that's a C library, and just in C it was not right, and it's still not right today. And they're like not interested in like fixing problems. They try to hide problems that they cause and stuff like that, but they don't try to fix them. So that was kind of an annoying thing with Haskell. It's not like, I don't know if I can show it. But anyway, this was me trying to do, let me, do I have a Haskell one here? Man, this is like, I haven't touched Haskell in so long. I don't know if this is going to build or play or what is it? Stack, run, something like that? And my Haskell code is probably not very good. Yeah, let me just see if I can do this. Is it stack? I feel like it's stack. My system has probably been recompiled and rebuilt so many times. Not. It is stack, right? Do I not have stack installed? No, but I'm trying to run the project. It's just like sorry, it's been a long time since I touched Haskell. Is it just, this is probably just like not going to work, but let's see what happens. Yeah. The other thing is my system is not up to date either. Come on. I'm messing myself up with this keyboard. Well, just why? See if we can get the latest packages. So, right now, it's really popular to talk about what is it? What is it? Hyperland. Everyone to talk about Hyperland, and they got this. It's Arch, man. Everybody's using Arch, but it's Hyperland because DHH said so. So I broke my system trying to use. It wasn't the DHH version of Hyperland. It was the other nonsensical one that was popular before the DHH one. It was just some shell script that totally f's up your system, right? Don't run people's shell scripts. So I did that and I screwed up my system and it did get me into Hyperland, which is fine. I was like, okay, this is some pre-configured version of Hyperland, but also it screws up your entire system. You like it. I had KDE already installed on my system, and it was completely broken, and I could not pull it back. Like it was like their scripts were actively breaking, like you have no idea what's been done. You either need to install. Oh, this is a rabbit hole, isn't it? But so what happened is I had to reinstall my operating system because I broke it running some whatever the Hyperland pre DHH from like 2 or 3 months ago, whatever is the big rage at the time. And I do want to try Hyperland again at another point, but I do not want to use somebody's pre-baked script that screws up my system and that's changing a bunch of stuff. It's not, you can't just remove the package. It's changing, it's like it's just randomly writing a bunch of files, deleting files, putting things here and there, and building stuff from maybe the AUR. And you have no idea what happened to your system, and it's totally screwed. So everybody's jumping on the DHH hype train, thinking they're running Arch Linux, and they're not. They're running Ubuntu that's called Arch Linux. It's not a real. Hold on. The reason why I'm talking about the Arch Linux and stuff like that, there is a reason people use Arch Linux. Memes aside, I did not know about any of the memes when I started using Arch Linux. Where I came from was I had built my own Linux system like 15, 20 years ago. I saw Linux from like when a class I took in school, and I thought this is really cool. I don't know what this is, and I saw magazines and stuff like that. So I started playing around with it, and then I had no clue anything about Linux, and so I was like, well, you can just like make your own, right? And so I started playing around with like Slackware, and then I tried Slack's live scripts to make my own. So I ended up cobbling together like Slackware and like a bunch of like Mandrake and OpenSUSE stuff like this, packages like that do not belong together, and was able to get a bunch of games working. So I had this game system thing, and it was my own thing. It was called Maya OS. So I created that, and that obviously was terrible, but it worked, right? So then I was like, well, I should do this correctly. So then I started using Linux from scratch. So I built an entire Linux from scratch system, but not just build it. I created like I didn't know how to program. I'm not a programmer, but like I don't know anything about programming by trade or anything like that, or schooling or anything. And so this is just a long time ago, me just being like interested in computer stuff and not knowing anything. And so I start making my own package management system, not knowing that there's only like 4 or 5 of them that actually exist. I didn't know this because that was like I was just way down a nerd rabbit hole. And so I'm making what do you call this, Linux from scratch, packaging everything up separately and making a package management system that was written in Bash. And again, I didn't know how to program, so I thought Bash is not a programmer thing, right? So I'm making my own update system and to the server and everything else in Bash. And I made my entire system, and it was my own everything. And then I was doing like 4 or 5 different desktop environments. I did GNOME, I did KDE, XFC, Enlightenment, LXDE, and all this stuff. And yeah, so I did that for a while, and then I just stopped. Yeah, I did this on a I don't know if you've seen this. I think was it LGR, or who's the guy that has the retro tech? This stuff's still compiling. So some dude has a retro, what was it? Hold on. It's a Inspiron 9100. Somebody has a video on one of these things. Yeah, it is LGR. So I'm not going to play his video, but he's got a thing on this. This is the machine I made it on. So I made Maya OS on this machine here. That was I think a Pentium 4 or something like that. It was like a Pentium 4. It had hyperthreading. It was a single core processor with hyperthreading, and yeah, and I built like I didn't have any concept of like people don't do this. Oh, Haskell. Do 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 do. Oh, can I mute the music? Oh, cool. I can mute the music. So is it working now? Where did this come from? Haskell. Yeah, and this guy. So this is Haskell. Yellow Snow. But there's some issue that happens. Let me play the music, and it's the music stops playing. It stops working. But maybe it's been fixed. I don't know. Maybe it was a kernel thing. I haven't tried this in a while. I'm just amazed this compiled and worked without it. Just that's just amazing to me. Like I thought it was totally not going to work. And I would love if somebody actually knows Haskell to tell me how bad my code is or what I'm doing right, what I'm doing wrong. Like Haskell is super fun language to me. I don't have anything bad to say about it. I don't know if it's the right language to do any actual work in, but it was super interesting and fun to make projects in Haskell and to learn about Haskell and go down the insane rabbit hole of like the set theory, the monads and stuff like that. I still don't understand them correctly. Like I don't want to explain to somebody else what a monad is because I'll get it wrong. I'm still interested in it, so I will definitely get back to Haskell again. Like I have bad memory. Oh, it's totally working fine. This is so frustrating. But before the music would cut out and it would stop working, and I could get an error message, but I had no way of looking this error message up. And I was going into to where the error message was coming from, and like I think I was all the way down into like the SDL. The error message was originating from SDL, and it was basically like it was querying. Like, can I change the? It was like if I run the. I'm assuming this is using delta time. Where am I doing FPS? Game FPS is so delay, so on. But am I statically running 60 or am I doing delta time? And wait, do I have an output of, yeah, okay, I'm at 60. So I got an FPS output. And just gonna look for FPS somewhere here, FPS delay. So I'm not setting the FPS anywhere. Importing. Where's this 60 coming from? Not from here. Am I pulling something in from this? Collision flags game config, maybe here. Okay, we got some stuff going on here. There we go. Okay, so let's try to run this faster. So let's say like I don't know if I have delta time, so we'll find out. Let's try to run it at 1,000. That's correct. Okay, F. Okay, so it's running at 1,000 FPS. So when I would be running at like 60 or, oh, there it goes. The music just stopped. So I didn't mute the music. It just cut off on me. And you're saying, well, I'm running this at 1,000. The problem is it would be doing it when I was running it at 60, and I like had no clue what was doing this. And again, I've asked the people that do the binding for this, and just never going to hear back from them. It's a ghost town. So like the problem is if I want to make videos telling other people how to do this, I don't want to tell you you can make a game in Haskell and then your sound doesn't work. That's going to be super frustrating because you might invest a bunch of time. You might be really excited about Haskell and I want to make a game. This is going to be amazing. There's no reason why you shouldn't be able to make a game. You pick whatever language you want to use, whatever makes you happy. But like, if I can't tell you how, at least the best of my knowledge, to make it work, then it feels really bad. It feels like, I'm reluctant to now make this video and show people how to do stuff in Haskell because it's like, and I don't know if I did a video for this. I did a beginner's guide one. I'm not sure if I did this project itself. Was it in the, what was that repo one that I had open? I have a bunch of projects on here that I never made videos for. Xmonad. Oh, I was recording most of my videos in Xmonad too, which is also Haskell. It was a Haskell desktop. So if anybody likes Haskell, there's also a Haskell desktop called Xmonad. It's pretty sick. It does have some downsides to it too, though. But it was fine. Again, the only reason I'm not using it right now is because I was having issues with this laptop specifically. And then I did the Hyperland thing and had issues with that too. So I would probably be back in Xmonad again. I just have to have some time set aside to actually do that because what happens is I have 15 things I want to do and KD's right here and KD works. So even though I do actually like the tiling window manager, I would either have to set some energy and time aside to set Xmonad up again or to try to figure out Hyperland from the ground up because I don't want to use somebody else's script. I don't want to use DHH's trust me bro script that breaks my system. Now I tried so many things. You have no idea with the music file. I tried to pull the music file in. I tried to do it like mono, multiple, MP3, OGG, FLAC, whatever. Tried to do it at like 41. Was that 4100 hertz or 4800 or 48,000 hertz or 4100? What is it, 4150 or something, whatever the ones are. I tried every iteration. I kept trying and trying and trying and trying, and it was so flaky. It would work sometimes, it wouldn't work other times. And what's the music? So you see these, there's different versions of the audio file, and then there's I tried way more than what you see here. This is just like me trying MP3 OGG wave. I'm trying wave files. I can tell you none of them work correctly. It's so frustrating because you're like, and I posted my video. I got so angry. It was one of the last times I probably posted code because I wanted somebody else to look at my code and tell me what I'm doing right or wrong or what direction, because if I'm learning, it's nice to have somebody tell you. Let's see if we have my thing. Sorry. I hate this so much. So I think I tried to, like, this is probably an old version. I was asking, hey, is this correct? Am I making any mistakes? I was hoping somebody else that likes Haskell would be like, yeah, you're doing a great job, or you might have potential problems here, or this might be like a memory leak or something, right? Um, the or was it? Don't know if this is the one. It might not be this one. One of the one I was like, could you review my code? And some JavaScript person was like, well, you said there might be a problem with the audio, so we're going to have to close this and say it's answered. And I'm like, I just want to review. And they're like, nope, we can't review code unless it's perfect. And I'm like, thank you for that JavaScript input. I'm trying to get help on Haskell here. And it was so bad. It made me so angry that I never asked help again. And so now I'm stuck in the land of the vibe. What do you call it? The AI, may be lying to you or may tell you if you have a bug or not or whatever, which is nicer than not getting any help at all. But like, it's not great. So yeah, if anybody does know Haskell and stuff like that, that would be great. Yeah. So my idea, yeah, I get what you're saying about the like it's very niche. The Haskell and SDL becomes a very tiny group of people. So the thing that I was thinking might be happening is the when you have a game loop in Haskell, it's basically you have no state, right? So like you're putting the last your input is the output, right? You're running it recursively, and I was thinking maybe it's checking the state of the audio playing like rapidly over and over again, like 60 times a second. Are you still playing? Are you still playing? Are you still playing? Or 1,000 times a second, right? And then it's getting some kind of race condition or something like that. Or it has nothing to do with maybe the Haskell code itself, but like the binding to SDL or the way that SDL is doing the audio streaming. It's like asking it too fast, too many times. Like, are you done yet? Should I replay? Because the music has to be looped, and even if I wasn't to loop it, even if I played it one time, it would still do it. Because I think while the music is playing, it's basically checking the state of it every time through the probably because of the way Haskell works. But that's just a guess on my part. I like have actual no knowledge of what is causing the problem. There was an error message I got, and I did raise a bug about it. Where's the bindings? Because I did try to put some effort into finding out what was going on. So Haskell, so yeah, still two bindings, and I did it in the mixer one, I think. But again, that like there's nothing's ever gonna come. Sure, I don't even know how to look for myself. I'm able to get mixer issue. Yeah, here we go. This is me from March. And this isn't when I first had the issue. This is just me at another point in time coming back and saying, I wonder if I could get somebody to like, and there's just like no reply. Like I've switched to OpenAI. I have no idea what this person's talking about here. Um, what are they talking about switching to OpenAI? Like I'm using what was it, Pulse Audio and uh what's it called? Not it's like the Pulse Audio binding for What's the current audio system in Linux? The WireGuard, Wire Plumber. What's it called? Whatever the audio is, that's like Wire Plumber uses. Yeah, so I'm like OpenAL. OpenAL sounds like from a super long time ago. That was like after OSS or something. So I have no idea what they're saying. Like I just don't understand it. Also, this is from November 2024. So this is a year. Oh, okay. Yeah, this is a long time ago. Yeah. Yeah, like I haven't like the when I was first learning Haskell was like the very early days of the AI stuff, and the it was just like I just like well what I didn't know how to ask the AI for questions. So I would just like try to tell it to explain something to me and like try to figure out how to just write like one function. And you just could not do that because it would just hallucinate. Like it understands that Haskell is immutable and doesn't mutate variables, and yet it would just mutate the variables. I'm like, but and I didn't know Haskell, but I'm like, I don't know what these things are, but aren't you mutating this variable right here? And like, yeah. I'm like, but you can't do that in Haskell. And it's like, oh yeah, you're right, you can't do that. And it would just give me, and it would literally give me 1,000 versions of a function that didn't work. So I would be like trying to get understand each and everything, and it's a little bit hard when you're like in the deep end of a pool and you don't understand everything around you. But I did get better at it. Basically, I went down and I oh, this was the error that I was getting specifically. This SDL call failed, SDL exception caller, and it failed silently. But this was like the one bit of output I could get. But it was this OV times seek to false, and again, I tried to find this like the SDL code, and it didn't actually give me an answer. It's like I don't have enough knowledge. But anyway, so like I was actually the AI was helpful in enough where to help me to understand the documentation for Haskell a little bit. So, but not to show me anything. It could not write Haskell. It couldn't write a single line of Haskell at all. So if I was writing a line of Haskell, I could ask it what some specific thing was, and it would give me 50-50 whether it would give me the right answer, right? Which is still pretty good because like I could ask it 5 times and I would pretty much, and then I could look it up and like, oh yeah, it does mean this thing. So I was able to figure stuff out with the help of AI, but like the AI could never give me an answer on anything. And with Bash, like today, like, oh my God, I don't know how anybody says you can vibe code because I could not get it. Like, if this seems to be like, let me ask. I don't have any special AI tools or pay for anything. I just do the free, what's it? The stupid Bing one. So, okay. So, I had this problem where I wanted modulus of 360, but I wanted to be able to handle wraparound. Okay. And I couldn't think off the top of my head how I would do this. And I didn't want to think about it too much. I just wanted the answer. I knew it was going to be a one liner. So I just wanted the answer. I was like, how can I get the wraparound? All right. So I asked the thing, like, in bash, how can, oops. Okay. It's going to make sure I'm human. Um, let's say what I need. I need a number clamped to 0 to 360. Yeah. Something like, what's it, mod? But I need to handle negative numbers 2, as in I were to give it a 180, yeah, well, whatever, it's a negative. I don't know if it's going to understand that double negative. It would be 180, something like that. I don't know how to explain it, but I want to use modulus, but I wanted a negative. I wanted the inputs to be negative numbers too, but not give me a negative number, to have it clamped to that, right? And modulus can't do that, I don't think. Yeah, okay. What's the code? This is okay. So like, I didn't tell it bash. Okay, it's already given me the answer down here, which is not the answer. It sort of is the answer, sort of, but I didn't explain it well enough. I don't know what the bounds on the input will be. Large or small? The income. So this won't work right here. This clamp thing won't work. And I spent like way too much time arguing it. I'm like, no, this won't work. This won't work. This won't work. This will not work. Right? Wait, what? So n 300 plus 300. What is this? Okay, so I just want to know what it's saying here. So if I have my input as negative 9999, right? And I do modulus, I'm going to get a negative number. Plus or modulus. This isn't right, right? Does work for any integer. Maybe I'm stupid. Now I feel like I'm going crazy. Negative equals 0. What? If anybody's watching and you actually know the answer, let me know, because maybe I'm just really dumb. Because this right here, I don't understand this. Mod doesn't deal with negative numbers, does it? Maybe it can. Maybe I'm just crazy. Let's what is, no, I'm triple. So I could just be crazy. I could just be wrong. I came up with a different solution though than this. The operator syntax for modulus pronounceable. Okay, cool. Returns value. Yes, but can it do it? Can it handle negative numbers? The modulus division. If y is 0, then divided by 0 is compile time error. Well, that's not good. Now I'm tripping. I might just be really dumb. So we have -3 mod -4. What? And it gives us -3. I could just be not understanding modulus at all. I swear it had something to do with negative numbers, but I could just totally be wrong. So they differ with maybe it's the real one can't, but the one can. I don't know. So let's see. It's saying it can handle it, huh? So give me, can a modulus be negative? Can. Requires A, B is represented. I'm down a rabbit hole. It's just me. I'm dumb. I'm the dum-dum. Different respect to negative values with a remainder operation. The sign of the result is the same as the sign of the divided. Okay, so what was the thing that it gave me? It did a modulus on top of it, though, right? Where was that? So we have a negative number here. We get a negative number. Then we add 360 to it. We still have a negative number. Negative. No, this is still bullshit. What? What? Because I don't want a negative number. It needs to be in the positive space. So if this is -3, I'll have a -1. Oh, okay. I see what it's doing. So this clamps it. It's still a negative number. Then I add the 360 to it, and then I do the modulus of again. Fair. Fair. This will work. Calculate the remainder. Yeah. So this isn't what I did, but this, yeah, I get what it's saying right here. So, because I was frustrated because I was like, I don't want a negative number, but this is clamping it. So the negative number is only, negative up to 360, and then we're adding it. So it gets it into the positive realm and then getting the modulus of that so that no matter what, we are in the positive realm. So that's fair. That is an answer. I was confused. So what I was dealing with was this. Where is it? It was in Bash. The one of these guys. Oh, I know what it was. So let me show you something else. Let's see, and this might mess up the stream or not. Sometimes it does. Examples, and then we'll say the text one. Text. Is it test? Text. Right. So we have these text moving around the screen, And then I can also make them change, right? And I don't think I'm getting great FPS. Where's it? There it is, 60. It's still doing 60, but when I do it everything, it's going to drop down. It can't actually. This is me doing 200 bubble objects. So these objects are actually, this isn't actually a problem of information going between bash and C. That's the problem here. The problem is every single one of these 200, I am recreating their image every single frame and changing the color of it and changing what is on the image. And then I could rotate it too. So it was the thing with the rotation. I wanted to make sure whatever number people are inputting in from bash, when it gets into the C land in the server that's running this, it was correct. I was trying to be safe. So I was trying to think how I could clamp it and always have it be a positive number, and my brain wasn't working. I came up with a different solution. I inverted the number, or inverted the sign, and then inverted it back again. Server. So this would be, this is like a rotation of the text, probably in here. Is it angle? So this one, if I have an angle, I'm giving it an angle. Some number is going to come in, right? It's going to be a float. The number coming in from bash can be a float, and then I want to rotate it, but I wanted to make sure I wasn't really worried about what SDL could handle. I wanted to make sure my number was between 0 and 360. So if they're giving me like negative 365, it will just like be negative, or it would be 5, right? Is that negative 365? Something like that. Yeah. It would just be 5 instead. But what if they give me like negative 700 or negative 1,000 or whatever? I wanted it to always be clamped, to rotate, always be the right one. So I think in here, I'm just pulling in a float. I'm just making sure that it is actually a float. I have a function that to make sure that this number is, they didn't put in Bob instead of a float, so it wouldn't crash the thing. So I have a thing that makes sure it's a float. If it's not, it'll, let's just show you what it looks like if you like were to put the wrong thing in. So this is and I'll just use the text one that we were just playing around with. So here I'm having some spinning of the text, and this is like a test thing. So this has a ton of duplicated code in it, so I could test it like 9 different ways. But we want the rotation on the 9. When we're in 9, where is the rotation? String color. 5. Okay, here it is. So we're updating text angle, and we're putting in the. Am I doing this all at once? For each text object. Oh, okay. So I have an array of text. Basically, they're you get back into bash, you get back an ID, which is just a number. So I have an array of all the IDs of the text objects that exist that you've created, right? And I also have a separate array of rotations. So this array of rotations is just in bash. And so I am rotating it. It's like the acceleration of the rotate by delta time. So this is the call that I'm sending. And it's going to basically loop through all of the text items. There's 200 of them. And it's going to update their rotation based on how much their velocity rotation. Each one of them has a different amount that they're rotating each time. And it does that. So, but what happens if I were to like put in here, this is the angle velocity. What if I was to put not a number here? Like what if I, like it could be 1, that counts as a float, or 1.1, right? That should work still. So let's check that, and I'll put it on 9, and it still works, right? And nothing broke. Things are all rotating the same right now at a slight angle. But what if I were to put something that's not a number, like Bob, right? This is a problem. I needed to shut down gracefully, right? So I press 9 and then it dies, right? And it says error, Bob is not a valid float. So I needed it to do that. I needed it, for one, I needed to check that the number is really a number. And two, I needed to make sure that number is clamped to 0 to 360. So I was trying to figure out how to do that. And I was like pulling my hair out. And I was thinking that it gave me a bunch of other answers first. It was like, I was like, it might be bigger than negative 300. And it was like 720. And I was like, no. But I believe I just inverted it, is what I did. So this is the parser. Sorry, that's not the parser. This down here is the parser for the text. Hold on. So this is the parser, right? So it's calling this right here with the ID that you send in and the angle. Yeah, this is the all this is the parser. So it takes in a string and it parses stuff, right? And I tried to make it like I could make it faster. So yeah, let me show you the modulus thing, and I'll show you a bit more because like I went down, like I was just learning how to do things. It's crazy. You can actually delete things and create. It does memory management and everything. In Bash, you don't need to worry about it at all. But it's all written in C. So this is just parsing that. So like the person literally sent in angle, and then after angle there is some number. So I'm sanitizing it, make sure that really is a number, and then I'm making sure the ID is really the ID, because you also need an ID of this text object. So I'm making sure that is actually an ID, and then I call this function. So let's go to this function. And this function is here, but it's not here because that's the header. It's actually in C. What was that one? It was like angle or something. Set angle, maybe. Update angle. Oh yeah, but it's probably using delta time to update. Yeah, it is using delta time to update the angle. So this is what I ended up doing right here. This was me, and it's a float, so I'm using f mod f. But basically, I'm flipping the sign and then flipping it again. So I take the 360 minus whatever the negative angle would have been of the f mod, right? So I always end up with a positive. I'm basically getting the modulus of the negative version and then subtracting that from 360. So I always end up with a positive. That was my implementation. It could be just terrible as well. But the other thing I was doing with these, let me close this and close this back here, is a lot of times I was I was testing the speed at which you could talk between a bash and C, because that's very important. I need that to be very tiny, very very fast, very fast. So like one of the ways you could get around this, even if you did have fast speed between bash and C, is that you could send it an array instead. So instead of me telling it to draw like say I need to move 100 or 400 sprites. Say I need to move 400 sprites. I could loop through 400 sprites and send a signal to C saying, "Hey, move this sprite 400 times." Or I could send one time all 400 sprites and say, "Hey, move all 400 sprites by like 50 or something like that." So I'm doing that in here a lot. So a lot of times I'm doing an array. So right here I'm doing, let's see, what is this one? Oh, this is I'm not in the parser here. Sorry. So this one's an array. So this one, it says update text, and you can choose an X or a Y that you want to update. And then you give it a float, and I put the float first instead of the ID of the rect. This is specifically for a rect. Sorry, this should be text, not rect. I must have grabbed it from the rect code. This should be These are still the same. This is still the same. This is all fine. This ID is a text ID. Because I do have recs separately, but they don't deal with text. Texts have their own recs built into them. So basically, so I say, hey, like whenever I say update, I'm going to use delta time. So internally, this thing is keeping track of whatever speed it's moving at. So if I say move 300 and I'm at 60 FPS, it's going to move by, sorry, is that right? 360 FPS. It's going to move by like 5, right? Yeah. So if I'm at 60 FPS and I tell it to move by 300, it's going to take the delta time, multiply it by 300, and I'm going to end up with 5. So I could say, hey, update. When I ever say update, I'm using delta time. If I was just setting it to a spot, I would say set. So I say update text, and I'm going to choose one of the other. It's going to be an X or Y. So update text X, and then I can say 300 here, and then I can give it an ID of 200 or 400 different text objects, and it's going to move all of those, like with delta time 5. Like if it's 300 now we're at 60, it's going to move them 5 to the right or something like that. Sometimes you can't. You need to move things separately. So that text one, I have like literally nine options you can choose from. I'll show it again real quick. Let's undo the change that I made to that text, the Bob part. I already did that. Okay. So here, what I was testing is if I go here, if I press 1 and press F, let me turn off let me set this to like 10,000 so I can just get as fast as it can go. Okay. So what this is going to do is it's going to draw 200 text objects. Okay. And right now it's getting around 80, right? This is on my system. Your system may vary, but this is like the dumbest way possible. I'm literally looping over every single thing separately and telling them all to update separately and telling them all to draw separately. So I'm telling all 200 in a loop. You draw one, draw the next one, draw the next one, draw the next one 200 times. So if I press 2 now, we're going to see a little speed up, and it's going to be that everything is still the same except the draw thing. It's just going to say, hey, draw all 200 at once. It's just draw text, and then 200 IDs are chucked into there, and it's going to do them. So I'm going to press 2 here, and let's see. Actually, it looks like it didn't change much. Still kind of hovering around the same spot. But anyway, I did press 2. So if I press 3, it's going to do a different thing. It's doing, I can't remember what all the numbers check, or what the code changes in all the numbers. But it's checking bounds collision off the edges of the window. And it's doing that for each one separately, I believe. But you can also say, just give me, instead of for all 200, it's checking getting the left, right, top, and bottom separately and checking them all and then changing their velocity. You could say, hey, you know what? For each one of these 200, give me the left, right, top, and bottom all at once, and then I'll check it. So I'm going to press 3, and that should speed up, hopefully. Now it's at like 140. And also, what's even better than saying, hey, for each one of these 200, give me the left, right, the top, and the bottom all at once, I can instead say, for all 200 at one time, give me the left. Just give me an array of all the lefts, then array of all the tops, array of all the rights and the bottoms. So that's 4 send and receives instead of 200. And now I have the array, and in Bash, I can do my checks. So I'm going to click 4, and that should be that version. And it sped up again. It's around, it's bouncing. It looks like it was like maybe 200, but down to like 140. I don't know. It's around 190 now, stabilizing. So that was that version. And then I was like, well, what if and this one will kill it. This is really going to kill it, because the fact that each time this bubble around each of these texts, I'm actually doing that in software in C by stamping it around in a circle as white and then center stamping it as the yellow. So this is very time intensive. So I'm going to tell it to change each one of these text items. I'm going to tell it to change what they are. And I'm going to use it's something like the X position as their number. And I'm also going to use the other ones, what is it, the velocity and the height or whatever the other ones to set a color. So when I press 5, it's going to be the dumbest version now, but it's also going to be changing the number, the hello to a number, and changing the color every frame and regenerating that bubble text thing, which is a software kind of hack that I'm doing in C. It's going to do that every single frame. So it's going to slow way down. So it's very, the frame rate like just totally died. So this is it, changing the number each frame. And so I can do the same thing where I make it better. I press 5 here, it should make it a little smoother, 6, a little smoother, 7, because I'm doing the better things, but it still realistically has to, for this, the bottleneck is this making this bubble text. It's really hard for it to do. And this is single threaded too. So if we get up to 8, it's the very fastest version of this, but this is not really telling the story. Let me take away the bubble text. So this right here, the text objects, I don't want them to be bubble anymore. So I'm going to remove the bubble part. And I need a bubble size over here. So I'm going to remove both of those. This for the, sorry, what was this for? Create text. Oh, this is the FPS. I'm going to leave that. It's not the FPS. It's the 200 text objects that I want. It's up here. It's in this generate text. So I'm going to make them not bubble for this. And we'll see. It's going to perform a lot better. So the FPS is still bubble. So when we go to 5, which is the slowest of the generating, it does this, and then 6 goes faster, maybe a little bit, 7, a little faster, 8. 8's pretty fast. And then I was like, well, what if I rotate them every frame? So 9 allows me to rotate all of them every frame to their own. They're rotating a different amount using delta time 2. And this is not meant to be a game. This is just meant to how far I can take things. You know, like if you made a game, you might have a bunch of objects moving around the screen, and you may need to check things on all these objects or move them or do different things. So I was like, realistically, what kind of performance could we get? And I think this is amazing that you can do this with 200. These are, like I said, text objects in C. So like each one of these things has its own, what its text is, what its location is, what its rotation, all that stuff. It's holding on to its own information. So if we look at it and see here, so I have a like a management system thing, a buffer. That's what I call it. So all the kind of objects that I make, I have objects as in a text object, an image object, a rect object, or a sprite object. And a sprite object is just a rect and an image together. And a text object is the image, the rect, and its last text that before you changed it, and the color of the text, the color of the inside, outside. If you want a bubble or not, you can set them to bubble or not, or change them on the fly. It still uses the same object. So that is here, it's like in this buffer. So let's see, I feel like this is bubble, not buffer. I clicked the wrong thing. That was my bubble. That's how, like, if anyone wants to know how to make bubbles, how to make circles, this is how you make circles. Let me show you. See if anybody recognizes this. So this is the way I make circles. Okay? And if you see the sine and cosine part, you probably need glasses because there is no sine and cosine. But this is the I can't pronounce it, but the Bresenham's circle drawing algorithm. Pretty cool. Let's see if we can find a web page showing it. Bresenham's. Okay. Oh my god. Midpoint circle drawing. Oh, that's probably going to get there. So this is what I'm doing right here. This is how I'm drawing circles, or how I'm drawing those bubbles. Is I'm using this guy right here, this algorithm. This algorithm doesn't use sine or cosine or anything. It just does some addition and subtraction, whatever. I think there might be some multiplication. and you're seeing it draw the circle, but it actually only does one of them. It's only doing this one right here, this green one. So imagine you're doing this green one. You're calculating this green arc right here. Well, the rest of the circle is just the inverted of it, right? If I go the opposite direction on the X, I get this side, right? And if I go the opposite direction on the Y, I get this side. And if I go opposite on the X and Y, I get this side. And if I invert, I get, you know, so this gives you the whole circle, and there's no sine, cosine. And that's what I'm doing in my project here. But I can use the circle one. This is the polar coordinates trigonometry algorithm here that uses sine, cosine, radius, whatever. And this is the version I'm using is the other one, this one. And this radius right here, that's not a function. That's just me saying the radius, like some number that I'm putting in, which is an int. So what we have here is a subtraction and a multiplication. We're checking equality. We have some subtractions. There's a multiplication here. So the hardest it ever does is a multiplication. And it does 1/8 of a circle, and you just invert that to draw the rest of the circle. So here is just drawing the circle. This is like taking one each point and doing the 8, the inverted for each one of them. So that's pretty cool. What was I saying before that, though? I got lost. Oh, I was trying to go to my buffer. So anytime I make an object, I return an ID. Okay, so I have a buffer, and this is all the logic for the buffer. This is the whole thing right here. So this is my memory management system. If you ever ask it to make something, it's going to give you back an ID. If you tell it to delete it, you don't have to tell it to delete anything. But if you were to tell it to delete something, it's going to it's going to mark that one as not being used, or the ID. And if you ask for a new one later, it can refill that spot. But basically, this is an array, but it doesn't know what type it is, right? So I have to use it doesn't matter when you're pushing stuff into it what type it is. I use a union, so like it thinks it's different types as I push stuff into it. So basically, I have an image. This is one of the elements, so it's going to be all of this. This would be one of the kind of array setup. It's going to know the element size. The element size is the size of whatever I'm putting into it, because it doesn't know what type it is. And then this is the capacity. This is which one I'm on, so the next one. But I don't use it that way anymore. I kind of do. Like, imagine I put I give myself a buffer of 10, and then I haven't put anything into it. So the first one's going to get 0, ID of 0. The next one will get ID of 1, ID of 2, ID of 3. And if I were to delete ID 2, my increment thing is going to be at like 3, or a 4. So 4 is the next one. But what it's going to do first, before it does that, is it's going to say, hey, is there any holes that I can fill first? And then it fills a hole, and it'll return the ID of that. But if it doesn't, if this reaches the cap size, it's going to say, right, you don't have enough room for another one. I'm going to recreate, I'm going to recalloc new memory of 20 instead of 10, right? We started with 10. I'm going to increment again by another 10, and it's going to reallocate. It's going to copy over those 10 into the new spot, and then put that 11 spot in there. And the data is just data. It doesn't know what it is. But I can cast it as or I don't need to cast it. I can just read the data as one of these, because it's a union. So it's either like nothing when I'm generically pushing anything into this, but when I need to read it, because that's an array, I want to index it like it's an array. This is what I do. So one of these images is we can look at the Rex. The Rex is just very simple, right? Did I put the Rect here? I can't remember if I put it in. If it's in here, yeah. So this is the Rect. It's actually more complicated than I thought it was going to be. This is the Boolean. Is it used or not? So if it was deleted, this would be false. If it's used, it's going to be positive. This is the actual rect, the thing I'm worried about, right? But I also want to know the anchor of it. If I tell this rect to move around, am I telling it to move around by the center of it, or the bottom right, or the top left? So I've set up this anchor thing. I could probably simplify this into one anchor point, which I did in another project, but in this one, I'm using horizontal and vertical anchors. And then this is since I'm using SDL2, those are using ints. I'm holding this as a float, the X and the Y. And that X and Y doesn't mean the top left X and Y. It's whatever the anchor is. And then I have an angle as well. And then if it's flipped or not. So the rectangle, if I was drawing an image with a rectangle, I would need two rectangles, but I can put null as like one or both of them. But let's say I did use a rectangle as the second rectangle, the destination one. It's going to count that rotation on the second one. So you can actually use sprite sheets with this if you wanted to, because you can set source and destination rectangles and stuff like that. But you might not want to do any of that. That's way too complicated. So what you can do, there's another one which is just the images. So where's images? So images is more simple. Is it in used? And we're holding an image, right? So it's just an array of these. So when we get to a sprite, it's just the two together, right? That's not the parser of the sprite, the actual. So the sprite one looks a lot like the rect, but it also has the image. So here's the image, and the rest of it is all like what would be in a rect, right? It's just the two together. It just has its, and its source rect is always null because it's going to use the whole thing. When you're dealing with the sprite, it's always using its whole image. But when you get to it like a text, it's going to have even more information. It has a buffer. It's going to remember whatever string was created. Because if I tell it to create that same string again, and that string is not changed from the old string, it's not going to regenerate. It's going to be like, you're setting the string to the same string. So when I'm drawing FPS, I don't need to regenerate the FPS image at 60 every single frame. If it was 60 last frame and it's still 60 this frame, I'm going to tell it, hey, update that text in the update that text to say 60 again. But it's going to say, it's already 60. It's going to skip it. It's going to be like, you're setting it to the same number. We don't need to do that, because it's going to regenerate the image when it does need to. So I hold on to a buffer of whatever the last text is, because also if you change the color of it, if it said hello world and it was in blue and you said, now I want this text to be red, it's going to know that it was hello world before, and now you're just changing the color. It's going to regenerate the image from it. But this is the buffer size of whatever the text was, the font that was used, because you can change the font as well. So it's got to hold on to whatever the font was before. The image that gets generated, and it has a rect that's generated from that. I don't know what you're asking. What scrape what data? It also holds on to two different colors, the inner color and the outer color. Even if it's not a bubble text, the bubble text can be turned on or turned off. So every text object can or can't be a bubble text. It doesn't matter. It just holds on to two different colors. There's also an alpha, but the alpha is on the whole text, not one of the inner color or the outer color. It's the final texture that is created. The alpha gets put on it. That was the only real way I could get it to work. And that this is if it's a bubble or not, and it's going to be use the radius as the size of the bubble and stuff like that. The anchor is still the same, the angle flipped and all that. So yeah. So these things, all these different things I told you, they get put into the same buffer. I don't know anything about web scraping data. Sorry, I'm not. I don't do any web development at all. So I'm not. I'm not in that kind of that world. So I don't have that information. What is this up here? What Objective C++? What is this thing talking about? Where did this come from? Did I change something? Let me close these down. Oops. Did not know what... Okay, so I was still working on this. I want to save this. Where's my playing D? Do I not have one here? Oh, I guess oh yeah, here it is. Here it is. I do have this G in it. I don't know why it's complaining about. It should be fine. It's definitely not web dev. This is C. These are C files. These are header files. I'm also talking about bash. None of this is on the web though. I don't know why it's complaining about this. When I was just in that file, it was complaining. Maybe it's just confused about these H files. I'll have to look this up. This isn't a problem, but it's just annoying to see something written there. It's like thinking it's C++, but I do have... Maybe, hold on. I should put this in the... It isn't the top level. Huh. Let's see if I put it into here. It is actually like here. Let me shut off because it's been a while since I was on that. So the so basically you have two, like, let me see if I can pull up a neural network. You have the main problem is it's got to be integers, and you have a size problem too. So I just want one of those good... Where is it? Oh, I want to... Come on. I want a good image of one. A simpler one. How about this? Okay, so we'll use this image here. Okay, so so like imagine this is the little neural network thing going on, right? So these are my inputs, and what these are going to be in my yellow snow game, let me show it to you real quick, is the... come on. I don't have any files open. Let me open the file. This is... don't worry about the C stuff. This has nothing to do with what... nothing to do with the neural network. Okay, so here's the bash file that's running the neural network, and this is most of what you're seeing here is to talk to the ShellGame thing for the graphics, but the neural network is not using that at all. The neural network is written right here. So this is getting the inputs right here. So I have... let me just show you the game running real quick. And it's called Yellow Snow AI. I will just use network 1, that's fine. So it's running, right? I was running really quick. I can change the FPS back to 60, but anyway. So we have these flakes. So we have 10 white flakes and 5 yellow flakes. And basically, if you get the yellow flake, if you know about snow and yellow snow, you should never eat the yellow snow. Oh yeah, but that's I'm not making an LLM. This is a neural network for playing this game right here. So yeah, it is like... it's not like data science. This is like neural network, but not in that way. What it is doing is it's playing this game. This is a neural network to play this game. Let me go get my my monitor laptop is about to go dead on the battery real quick. Let me go get my charger. Hold on 1 second. Sorry about that. Yeah, the size of this network is not, in the range of like an element. The size of this network is like going from like 150 to like 500 or something like that. It's not very big. So we have 15 flakes. We have 10 white and 5 yellow. If you get to the yellow flake, I can just play a non-AI version of this. Pipe. This game is also working in Bash. So let's mute the sound. There we go. So I can control it and I can collect, these flakes, right? And then when you get to the yellow one, it's game over. So the AI one is basically, can the AI just play itself? Can it learn to play itself? So what I'm doing here is I take the inputs. So I have 15 flakes. I take the relative distance from the center of the player to the center of each flake. I wrap it. So if any of them are like too far on one side or the other, so they're always just relative. And since the stage is 800, it just wraps. So if it's like 500 on one side, it's going to be negative 300 on the other side instead. So I'm doing that with each of the inputs, and this is in Bash here. And then I actually am only interested in a range of from like I don't care about all 400 pixels away from it. I'm only cared about maybe 60 or 100 away. So everything else outside of that is going to be 0. And so normally it would the number would get smaller as it got closer to the snowman, but I invert it. So I'm inverting the number, and everything beyond it is 0, and then it starts going 0 up to the number, whatever that number is. So that's what this does right here for the positive and negative, again in Bash, for each one of the inputs. And then the yellow, I am only interested in positive number. I don't care about negative number. There's no direction involved. So I'm taking the same thing, the relative position of each flake to the snowman, and I'm just checking down here. If it's negative, I'm flipping it. And then I'm again taking the zone and inverting that zone. So that gives me the X with the what do you call it, with move to YouTube so I can do. What's PIP? So this is like the X needs to have a sign involved because it needs to know if the flake is on one side or the other. The Y doesn't. The Y I just need to know, is it within the range? So now X and Y are not important data separately, but together. So I multiply them. They need to be. And because I can't deal with floats, I'm not doing anything with floats. So let me just show how the network works real quick. So imagine this is the inputs, right? So I have 15 inputs because I have 15 flakes, but here's 3 inputs, right? So I'm taking the X relative to the snowman and the Y and multiplying them together. And that's going to be each one of my inputs. So that's like the first flake, the second flake, the third flake. Cool. And so my network is actually not these inputs. That's not my trained network, because that data is going to change every frame. So my network is actually these connections, the weights between the input and the hidden, whatever the hidden for each neuron and the hidden layer is. So this is what is in my network. And then also at the end, when it goes, it's going to multiply the input by the weight and the input by the weight, and it keeps adding them together, right? So this one input, whatever it was, times the weight, and then take that and add it to this input times the weight, add those two together, and then this one, right? So you have the answer of this neuron to all 3 of these is accumulated, and then there's a bias. And then we go to the next one and do the same thing. All 3, doon, and then we add the bias, the next one, right? So we are only in integer land. So what I did is I moved everything up 1,000 because this allows me to go sub 1%, right? 0.1%, right? So everything has moved up 1,000. So the inputs, I only ever move the game by 5. So since I only ever move them by 5 exactly, because like it's 5 pixels for each flake movement, and the snowman movement is 5 pixels because I'm locking it to 60 FPS. Since it's 5 and I want to multiply it by 1,000, hold on. Oh, oh yeah, yeah. Yeah, I'm not that very photogenic. Sorry. Probably would get more views if I was, or maybe less. I don't know, depending on how scared people are. My son wanted to play a game, so yeah. So because I'm in integer land, I can't do floats. What I need to bring it. I need to multiply everything, like the inputs, by 1,000, and then what my weights would be. This this weights needs to be multiplied by 1,000 too. So my weights would normally be like 5% or half of 1%. So if I multiply them by 1,000, I get like 50 or 5 or something like that, right? So that's easy. So my weights are already like multiplied by 1,000 because I'm not using decimals. My input should also be multiplied by 1,000, but it doesn't really matter as much as you think, because what's concerning to me is precision. I don't want to lose information. But I don't need to multiply my inputs by 1,000 because I already have this 5 pixels every time. That everything is done by fives. So I'm not getting any more information, right? So what I can actually do is divide everything by 5. I haven't lost any information by dividing by 5. Everything is still, instead of 0, 5, 10, at 0, 1, 2. That's still fine. That's still information. So I can divide it by 5, then multiply it by 1,000. Well, that's just multiplying it by 200. So that's what you see here. I'm multiplying it by 200 here on the inputs. So that gives me all the inputs. Now they're in this scale range of 1,000. So they're no longer in the decimal range or in the float range or whatever. And then so I'll show you one of the networks. This one has a hidden layer of 8. So this is just metadata in the front, letting me know my hidden layer is 8. This is my exclusion, or my zone, my range for my X, my range for my Y. This is how many trials it was trained on. This is how many generations it was trained on. This is how many times this particular network mutated. And this was the score it had at the end. You'd have to divide that by 2 because, again, I'm not using float, so I'm just adding those scores together. I don't know. I don't know if my internet is dropping out or I keep losing this connection. Hold on.